simple molecules. Simple molecules have a defined formula made of a few atoms held together by covalent bonds. So my first example is O2, held together here by a double covalent bond. Chlorine, another example, this time held together by a single bond. Should get the Cl's in there. We've got methane, held together by single covalent bonds again. This time we've got 4 hydrogens and 1 carbon. And then another example here is ethane, this time with 2 carbons and 6 hydrogens, again with single bonds. So if we have a look at all of these different structures, they are very, very simple little molecules, each one with a defined number of atoms. So in oxygen, a molecule of oxygen has 1 oxygen bonded to another oxygen by a double covalent bond. That is a defined structure. That's not going to make a giant lattice structure like you see in ionic compounds. Again, chlorine here is defined number of atoms. It's 2 chlorines bonded together by a single bond. Here in methane, again, we've got a defined number of atoms. We have 4 hydrogen atoms bonded together in an individual molecule of methane. Here we have ethane, again the exact same thing. We have 2 carbon atoms, this time we have 6 hydrogen atoms, all held together by single covalent bonds in a defined structure with a defined formula. So if we look at their defined formulae, we've got O2 for oxygen, that's a simple molecule of oxygen. We've got Cl2 here for chlorine. We've got methane here, which is CH4. And we have ethane here, which is C2H6. So these are defined formulae, and they are individual molecules that they end up forming. Let's focus in now on a specific example of a simple covalent molecule. So the one I'm going to look at here is oxygen. So we've got our simple formula, O2. So it's made up of 2 oxygen atoms, and they're held together here by a double covalent bond. And you can see that in the molecule that I've put together. So oxygen molecule. Now, if we have a sample of oxygen, what we don't just have one oxygen molecule around us. We've got millions and millions of oxygen molecules if we have a sample of oxygen gas. Now, the molecules themselves are held together here by very strong covalent bonds. Now, between these molecules are weak forces which hold these molecules together. So these are weak intermolecular forces. Now, these weak intermolecular forces that hold the molecules together don't need much energy to actually break them apart. So there's very little energy required to get these weak forces to overcome. So very, very little amount of energy required to overcome the force. So these molecules will move away from each other if you apply a bit of energy to them, and they'll separate and they'll move apart and they'll start to evaporate and boil at very, very low temperatures. We're talking minus 183 degrees Celsius to boil oxygen, to get these molecules to move apart from each other and oxygen to go from being a liquid into a gas. So let's just recap here. We have simple molecules held together by very strong covalent bonds. All bonds are strong, all covalent bonds are strong, but between these molecules here, we have weak intermolecular forces. They require very little energy to overcome. So if you apply enough energy to them, oxygen being the example, at minus 183 degrees Celsius, oxygen would turn from a liquid into a gas because these weak intermolecular forces require very little energy to overcome.